this red model X. The lighting, materials, and even the subtle reflections, aren't they exactly the same? Welcome to the world of 3D Gaussian Splatting. If you want to digitize real-world objects, it's actually not as difficult as you might think. 3D Gaussians use countless glowing, colored clouds to record light and shadow. Not only does it render incredibly fast, but it is also extremely realistic. In today's video, I will teach you step by step about how to extract objects from around you. Whether you are a beginner with just a smartphone or a professional player pursuing ultimate image quality, this workflow will work for you. Traditional photogrammetry often struggles with reflective surfaces, resulting in broken meshes. NERF, on the other hand, is essentially a neural network black box, making it extremely difficult to edit. In contrast, 3D Gaussian splatting is built from millions of Gaussian ellipsoids. Each ellipsoid holds its own color, opacity, position, and directionality. They faithfully record the exact lighting and the color variations captured from different angles, meaning the color and opacity of each ellipsoid dynamically changes depending on your viewing perspective. When you view this ellipsoid from the left, it might appear as a bright reflective white, but as you move over to the right, it could shift into a deep shadow. This algorithm perfectly simulates the reflection, refraction, and diffuse reflection of light in the real world. This is why scenes reconstructed using Gaussian technology look so real, seamless, and natural. Let's start with the easiest, phone-based video sampling. This method is perfect if you don't need extreme model precision and just want a quick way to capture a scene. Open your phone's video mode. It's best to lock exposure and focus. Then, slowly and steadily walk around the object in circles, capturing 3-4 rounds at high, medium, and low angles. While shooting video is definitely convenient, you must avoid any motion blur, otherwise your training may fail. If you want to extract extreme high-precision assets, you will need to step up to our advanced method, camera photos and 360-degree motorized spinner. However, we don't recommend the method of fixing the camera and rotating the object. Because when you are actually shooting, rotating the object itself, especially if it's reflective, changes the lighting, which will severely impact your final render. Now, let's begin. First is the setup. To prevent shooting from being disrupted by the background, you need a very clean environment, preferably a pure background, paired with stable, shadowless, soft lighting. Fix the camera on the motorized spinner. Adjust the aperture to be slightly smaller to ensure depth of field. Turn on the motorized spinner. Set the shooting interval, and the camera will take 30 to 50 shots as needed. Change the camera's height and angle, and repeat this a few times. The larger your effective sample size is, the more detailed your reconstructed model will be. How can you photograph the bottom of an object to make the model appear complete? Simply turn the object upside down or lay it on its side. Adjust the camera's tilt angle, and then rotate the motorized spinner once to take a series of photos. As long as your lighting hasn't changed and the background is a solid color, the Gaussian algorithm can automatically and perfectly stitch these photos of different postures into a complete 3D object during post-processing. Once you have finished your prep work, take your mobile phone videos or camera photo sets and process them in Reality Scan first. This will give you an area triangulation dataset and point cloud data. Then, import those into Lichfield Studio or PostShot to begin training. Go have some tea. By the time you are back, your model will be ready. You will find it looks incredibly realistic. So now you've already learned how to create 3D Gaussian splatting. Hope this workflow has inspired you. See you in the next video.